If you've ever spent any time in R to create slightly more complex graphs than you get when you use the default commands like plot or hist, you know it can often be very frustrating to get the graph to look exactly how you want it. I recently spent a fair bit of time playing with histograms, and this video will cover three examples of histograms that are commonly desired. So the first one, as you can see down on the bottom right here, is a histogram with a normal curve overlaid. The second one is a slightly different picture of a histogram with the density curve overlaid. And then third, a histogram that has a separate series plotted as a line with that line on a separate axis on the right hand side. So we'll cover all three of these different types of graphs today. So I'm just going to clear out of this so we have a fresh workspace. So the first thing that we want to do is load our data into R. And in this case, I have a sample data set that I've used that you'll often find whenever you're working in business. And what you'll often have is a summarized report like this one, where in this case the summary is by age. So we have ages from 0 to 20. We have counts of the number of people that fit into this age distribution. And then third, we have a series that calculates the subscriber percentage as a function of the number of people in the group. Okay, so again, you often see data like this in business, but a table like this isn't particularly descriptive. And so oftentimes, if you can make some sort of visual representation out of it, you can get a lot more understanding of what's going on. And that's what we're going to do here today. We're going to create a series of histograms to describe our data set. So we've loaded the data in, and now one thing we need to do is actually undo the summarization by age so that we can make a histogram of age. And that's what this function here does. The rep.int is to replicate the data that you have. And what we're going to do is we're going to take age, and we have the count. And what R does is just take the number of times this summarization happens and creates an expanded data set that represents the same representation. So when we do this, we can see that there's 7,545 people in our data set. And if we wanted to open that up, we would get something not so interesting. But ultimately what we can see here is there's a number for every single person as opposed to this being summarized. Okay, so we can work with this data set in order to create a series of histograms. And as I'm going through this, it may be a little bit difficult to follow the code that I'm actually running. The code for this will be provided on my website. You can certainly download the code there. I'll even put up the sample text file so that you can play around with this yourself. So first, let's just create a basic histogram. And what we can do is we can use this code that I've pre-written right here. Now, you don't actually need to do all of these parameters to do that. What you can do is just something very quick using all of the defaults. If you do a histogram, what you'll get is a picture that looks like this. So there's a main title that's somewhat descriptive but not too interesting. You have frequency on the y-axis. You have the name of your data series on the x-axis. And of course, you get your histogram. But this isn't the picture that I'm actually looking for here, because again, it's very default and not too interesting. So what I did was I added a bunch of optional parameters into my histogram statement. And when we run this, what you'll see, okay, is something that's a lot more visually pleasing. On the y-axis now, you can see we've gone from the raw number of counts to actually showing the percentage of accounts that fit into each age bracket. You'll also notice there's quite a few more bars than there were before. So rather than let R decide the breakpoints, I've specified the number of bars that I want using the length parameter, which sets the number of bins. And then you can see I've also created a meaningful title using the main parameter. And you can actually do this across multiple lines if you use the new line character. So there's a lot of additional parameters that I've added here, and again, it makes the graph look a little bit more interesting. Now, if we wanted to go ahead and actually do some more involved analysis here, we'd want to overlay perhaps the normal curve to see how normally distributed is our data here. If we look at down here at the graph, you can see that the peak in the distribution happens around, I would say, age 8 or 9. And then it looks somewhat symmetrical. But rather than actually having to kind of eyeball it, we can put a reference graph over top of this. And the first one we're going to do, again, as I said, was do the normal distribution. And what you can see with my code here is actually how to do it. And you can see it's somewhat involved. R seems to make things a little bit more difficult than they need to be a lot of times. So I'm using the points function, and it's a little bit hard to see here, but the way I have it spaced out is this whole grouping right here is actually generating data for the x-axis. And the right here, this function is generating the y data using the standard normal distribution function. And then finally, there's some additional information that we need in terms of what type of graph we want to actually show. So the type function of L means we're going to put a line on top of our graph, and then we're going to color it red to make it a little bit easier so that it stands out. And if we run this, you can see that we now have a normal distribution plotted over top of a histogram. And as we just talked about, the data is somewhat symmetrical. The bars are a little higher than they would be if you had an actual perfectly normalized distribution curve, but more or less we can see that our data is normally distributed around, like I said, maybe 8 to 10, depending on how you look at the age distribution. So this is one type of graph that's often interesting to do. The next type of graph, instead of using the normal distribution, if we wanted to actually make a density curve out of the histogram, we can go back and reset our plot this way. So now we're going back and creating the histogram. And if we wanted to just get a smooth representation of this graph instead of having the bars, we can do that using the density function that's built in within R. So whereas before I used the points function to overlay the standard normal curve, in this case we can use lines. And the reason for this is that R actually calculates the actual curve that needs to be overlaid, and we don't need to generate it ourselves. So when we run this code, what you can see now is not a perfectly smooth standard normal curve, but the curve that represents the distribution that we actually have with our histogram. And I've colored this one blue using the COL parameter, or color, again, just to make it a little bit more interesting. The other parameter that you can use here is the adjust parameter, and this represents how smooth you actually want your density function to be. So again, if we just go back up top here, resubmit, we get our histogram, and you can see I went from the adjust equals 2 to adjust equals 0, and what we'll see here is that the density, we don't see anything because adjust can't be equal to 0. Adjust equals to 1 will work. And what we'll see is now a curve that really, it certainly represents the density function that goes along with this distribution, but it's not smooth like we would expect to see. So if we use the adjust parameter, we can smooth out what we want to do. And usually 2 works really well. You can use 3. The higher the number, the smoother you're going to have the density function. So as opposed to the kind of weird looking density function that was just occurring, here you can see you have a much smoother line. And again, if we moved adjust up to 3, 4, 5, it would get smoother and smoother over time. So that's how you overlay a normal distribution or a density function on top of a histogram that you have. The final type of histogram I want to go over is much more complicated, if you can believe it. But this is the one where we're going to have a histogram along with another line series plot on top of it. So there's a lot of different functions that you need to use here. And this is what makes R so powerful but also so frustrating. So I'm going to go through all of the parameters here, try and explain them all. But ultimately, the best way to learn is to take this code and kind of play around with it yourself to get a better feeling on how each of these things work. So the first thing that we actually need to do is we need to again create our histogram, but knowing that we want to have a second axis on the right, we're actually going to put some margin space over here. And the way we do that is to use the par function with the OMA argument. And OMA represents outside margin area. And I've written the parameters that it accepts up top here. So the four numbers represent the bottom, left, top, and right. So in this case, we want to add a space of 2 on the right-hand side to push our curve over. Now when I run this, nothing's actually going to happen on the bottom right here because this parameter, or excuse me, this function that we're going to use is applies to all the graphs in the future. And this is a global parameter, so if you don't want to have all the graphs after this one have the same spacing on the right hand side, you actually need to undo this by setting all 4 numbers equal to 0. But anyway, let's go ahead and move on with the graph. So if we submit this, again, nothing happens to this graph, but we will see this in the future. So we'll go back, we'll create our histogram again, and what you'll see, if you notice it, is actually this graph shifted over to the left a little bit because again we're putting some space on the right hand side. Okay. So now the next thing we want to do is we want to overlay our line graph. And again, using the par function, we're going to say new equals t, so new equals true. So we're going to put a new line over top of what we're doing before. And the other thing that we want to really make sure of is the parameter here, which is on plot for the axes. And we want to set this equal to false because by default what R does, if this was equal to true, is it will keep setting the axes on top of each other. And in fact, let's go ahead and do that right now, and it'll be a little bit more obvious what this parameter does. So if we go back and run this line, you'll see that it's actually creating its own graph here. And that's not what we want to do. What we want to do is we want to have a histogram that has our graph, our new line graph, on top of the old one. So what we do is we set axis equal to false. Okay. We set a new plot. Okay. And what we get here is we not only get our histogram, as we talked about, we get a line plot, and then finally, when we set axis equal to 4, we specify where the axis for this graph should go. So in this case, 4 represents the right-hand side, 2 would have represented the left-hand side, and then 1 and 3 would represent either the top or the bottom. So again, if you play around with all of this code, you'll get a better feeling on how you overlay some of these things. Now, the one thing that's missing from this graph so far is the label on the right hand side. So on the left hand side we see percentage of accounts. This represents the histogram distribution. Now we want to label the axis on the right hand side, which represents the subscription rate line plot that we're doing. And what we can do is we can use the mtext function to do that. So what we have here is we want to write subscription rate as our label. We want to put it on side 4, which again is the right hand side. Outer equals true is telling this text function that we want to put it in the outer margin area, and that's the function that we used up here. We want to put the text on the outer margin. And then finally, the p adjust just represents where this label should be. If it should be left, truncated, right truncated, or top and bottom. So what you can do when you submit this, okay, and now you can see the subscription rate on the right hand side. So ultimately, with quite a bit of code, you can create some really interesting types of graphs. And the great part about R or any other language that you use is once you figure this out, you can either reuse this code by building a function, or you can just copy and paste from one script to another, as you need to redo this. So there's some value in kind of playing around with R to get an understanding of what it can do and creating your own code library. So as I said, I'm going to post this code on my website so that you can play around with the files. And hopefully this has been interesting for anyone who's been trying to do histograms that have additional information plotted on them.